Welcome to Code Crack with Raghu. In today's video, we are going to solve a very popular coding interview problem, Leetcode 53, maximum subarray, often asked by Amazon, Google, and other top companies. We will cover all possible approaches and step-by-step walkthroughs, space and time complexity, and best and most optimal solution, which is Kadane algorithm. Let's dive in. So this is the problem statement. Given an integer array nums, find the subarray with the largest sum and return its sum. Uh, we need to find the largest subarray which is having the maximum sum. So these are the inputs. Num array. Uh, Only the nums array is the input, and we need to find out the possible um, subarray which is having the largest sum. So here the output is 6, and the largest subarray in the above input is 4 minus 1 2 1, which is the largest sum array. The addition of all these numbers, right, it will give the output 6. So here 4 plus 2 6 plus 1 minus 1, so it is 0. So 6 is the output. So how this 6 came, we will see step by step. Three problem, we have three approaches. One is brute force, and another one is divide and conquer, and another is Kadane algorithm. So this is the input, and we need to get this output 6. So how, according to the question, we need to find the maximum sub array, uh, and addition of all these things, all the elements in a subarray will give the maximum sum. For example, in this input, right, we will take first minus 2. So let's put a loop here. For minus 2, how the loop will go? We will ask, for brute force approach, we need to keep two loops. One is for main loop. Well, one is a main loop which will take minus 2, and for minus 2 it will take all other values. It will compare, it will add, and it will check whether that sum is a maximum sum. If that sum is a maximum sum, then update the maximum value. uh, else else you can go for the next value. So this is the only condition here. So let's say I will take minus 2 and I'm going to compare this with 1. I'm going to this is a I value. Okay, I first iteration and I value, and here the second loop, that is j. We can say I is equal to 0, first iteration, and for this the value is 2 minus 2, and for this we have some set of iterations. For example, 1, uh, then one more iteration is for minus 3, and one more thing is for 4, and one more thing is for minus 1, and 2, and 1, then minus 5, then 4. The same, this is a j. Okay, j values, we need to add this. You need to check with all these values. What we need to check, we need to add the value with the current value, and check which is a maximum sum. If you found the maximum sum, you can return. You can update the value. Then the same I is equal to 0, right? Now I is equal to 1, which means 1. We will take a value, next value I is equal to 1, and for this I is equal to 1, then j is equal to I plus 1. Then we can go with other these values. Then for minus, then we need to take I is equal to minus 3, and you can go with other values. So like this up to the end, up to the 4 we will go, and we can calculate the maximum sum, and we need to update the maximum sum, and we need to return the end result. So this is for brute force approach. Let me explain through the coding. Okay, const max array brute force. Yeah, brute force. Okay, now we are going to implement the logic. Whatever I said, right? The same logic we are going to implement here. I am going to keep a two loop, one and second loop. So what are the values you need to keep? One is for max value, max sum. We can keep max sum. The value will be minus infinity. This is initial value. We will keep initial values minus infinity. And let's say this next one is array. We need to give this array, right? Let me keep it as nums array. We can keep nums equal to this array. Okay, now I am going to pass this array, and here I am checking like let I is equal to 0, initial value I less than nums dot length, then I plus plus. Okay, so what is the next loop? Next loop will be for j, and what I'm saying, the second value, first value I'm taking minus 2. Now I need to take for j first. So what I need to keep? I plus 1. So I plus 1. Here it will be j, and here it will be j plus plus. So that's it. So inside here you can calculate the sum value. So one is max sum. This value you need to update. Okay, max sum you need to update. Before that you need to calculate the particular sum. So let's say the keep let sum is equal to 0, and here you can keep sum plus, you can keep plus equal to nums of j. Here you are keeping nums of j here, and it will be the sum. And here need to find maximum is equal to math dot max of you need to check two values. One is sum comma max sum. So this is our logic. So once everything, for every value the two loops are done, right, you need to return the maximum. Here you need to mention okay, we are returning the maximum now. So this is fine. For what is the time complexity for what we have done, right? One will be order of n, we know, and this one is also order of n. Here is also order of n. So order of n, order of inner loop, order of n. So the overall time complexity is order of time will be order of n power 2. So we can check whether we are getting the result or not for this. This is not a recommended one, but we are checking whether we are getting a proper brute force. Okay, and we are keeping, and we are checking, we are running the code now. Okay, fine. Now we can run the code. Run this code. Code 53.js. You are seeing right now we are getting the expected output, that is 6. So what this code is doing, one is I am taking, already explained, right? One is for I, this loop is for I. It will take every element in the nums array one by one, and once let's say I am taking the first element. Now what I will do, I will check with all the other elements in an array through j loop. And what we are going to do, we are calculating the sum, and just check whether the sum and maximum, which one is maximum, that maximum value I am assigning to maximum. and once all the iterations are done right for I, we are going to return that maximum. So this is a brute force approach. It is having order of n and order of n here for time complexity. So it will be order of n power 2. The space complexities, we are not using any other data structure for saving the values. So it will be order of 1. So this is a brute force. It is not a recommended one for this approach. It's not a recommended one. We have other two approaches. One, the second one is divide and conquer, and third one is Kadane algorithm. So we will see the next approach. We will see divide and conquer. This is the second approach. So we will see how to solve this. How to solve this problem through divide and conquer approach. Okay. So we will be creating a function, and one more thing is we are going to create a helper function, and um, we are going to calculate a mid, left sum, right sum, and cross sum. I will explain what is this code and what we are doing, like left max, and we need to calculate right max, and based on this we will be returning the value. So here we will be doing a recursion. You got it right? So here you can see, right, this is the code. Now we have written here the initially the flow comes here, so max subarray, and whatever the values we are passing it, those are the inputs. For example, we are passing this input, this array, minus 1 2, this array. So here we are having one function, that is helper function, and we are having one more function, that is max crossing sum. So two functions we have written, and here only the execution will start. So helper of 0 comma that nums of length, so it will come here, right? What will happen, the helper will be getting called, and inside the helper we will be passing the two things. One is left and right. The left will be the initial value. So I will paste it here for a better understanding. So from here I will paste, you will be understanding easily. So you can see, right, the left will be 0, 0th index, which means the left will be 0, 0th index it will refer, and the right will be the end of the index. So nums of length minus 1, it will give the end of the index. So 4, the index of minus 2 is left, and the index of 4 is right. So we'll be passing these things to the helper. Okay, let me explain inside. So if you check, if both left and right both are equal, then it will be only one element, or only one. For example, I'm having only one element in an array, then it will return. So we can return that left. Else na it will come inside. And what is meant by divide and conquer? Divide and conquer na, we have some elements, right? Here we are going to calculate a midpoint. For example, let's say 1 2 3 4 5 6 7 8 9, total 9 elements are there. So what is the midpoint of 9 elements? We can split into 4 and 4, and 4 and 4 is 8. So the remaining one element is the midpoint, which means fifth element is the midpoint. We can say 1 2 3 4, and here also 1 2 3 4. So minus 1 is the middle element. So this is the midpoint. From the midpoint, these are the left and these are the right. So that only we are doing here. Midpoint I will be calculating, because left plus right divide by 2, which is the center element. So here the center will be minus 1. And left sum na, these elements, the left side elements, and right sum, which means right side elements, those will be calculated through the helper functions. And here also, this helper also, it will come here, right, the left right. So again here also the midpoint will be calculated. So again the same process here. This again, the function called inside a function call, right, we will be saying recursion. So here the recursion is done. See here the helper is there, inside the same helper function we are calling the helper again. So recursively it is getting called. So here we are doing recursion, and we are calculating the left sum and right sum. And what is the max crossing sum will do? Here is the function. What it will do, it will just take an array left, right, and mid. So what it will do now, that maximum we are calculating, right, that calculation is here only. Previously in brute force we will be calculating max sum, right, that calculation only we are doing here. For left will be separate max, and right for separate max, and we will be adding this both left and right max, and returning that maximum returning that maximum sum. So once the maximum sum is returned, we will be checking left sum is maximum, or right sum is maximum, or this cross sum is maximum. So whichever is maximum element, we will be returning that one. So here you can see, right, you will be having two separate loops. So this is one loop, and here one more loop. This is for left we are having one loop, and for right we are having one more loop, because this is divide and conquer, right? We need to calculate a midpoint, and left side we are doing separate calculation, right side we are doing separate calculation, and we are adding the both the left sum, right sum, and cross sum. So due to this, the time complexity will be right. So this is order of n. As we know, for iteration it will be order of n, and one more iteration. So for this also it will be order of n. So order of n, and inside order of n, and we are recursively calling this one. So the time complexity will be order of n log n. Okay, this will be order of n log n, because it will be calling recursively. So for here divide and conquer, it will be time will be order of n log n, order of n log n, and we will be doing, okay, we will run this code also, okay, to see the output, whether we are getting the same output like divide and conquer. Okay, placing those ones. It's max Subarray. Okay, now you can see, right, divide and conquer also we are getting the same output, and brute force also we are getting the same output. So but the divide and conquer, now we calculated, right, the time complexity is order of n log n, and here the time complexity is order of n power 2. So we need to see some solution which is optimal than these two time complexities. So we can go for a third approach, which is an optimal one, that is Kadane's algorithm. Here the solution is also simple and it is an optimal. A third approach, that is Kadane algorithm. Kadane algorithm. Here how this algorithm will work, right? First it will see minus 2, 1, minus 3, right? So what it will do, it will calculate the current sum and maximum sum. And the current sum value, right, it will be just updating if any, let's say here minus 2, and the new value, the next value is minus 1, 1. So it will check whether the, it's also having only single loop. The single loop, it will check from one by one, right? It will just calculate the current sum and max sum. For example, I am taking minus 2 and this value, the next value. So it will check, it will go for 1, right? What it will do now, it will just check whether the current value, which is 1, the minus 2 is a pre, okay, I will explain this way, then we will understand clearly. Like in Kadane, right, okay, I will add it end, so we can understand easily. uh, okay, so these are the inputs and output. How this Kadane will work now, it has two things. One is current sum, current sum and max sum. Okay, max sum. So for this 0, for example, index 0, index 0 iteration, right? What will happen now, it will just check current sum is equal to, we can say nums of I. Okay, comma, what it will check, current sum plus nums of I, whichever is maximum, right, whichever is maximum, it will take that value and assign to current sum. Okay, but the maximum, we are not having any constraint here. The maximum is the max of current sum comma maximum. You got it, right? So current sum plus comma maximum. So what will happen here now, like in this, these are the two things we are going to do in every iteration. Okay, in every iteration. So what will happen for minus 2, so here for the current sum will be minus 2. Here I will add max of nums of I is minus 2, comma, the current sum, which will be a default value, first value. You'll be taking a current sum as a default first value, so it will be minus 2. Okay, yeah, correct. We'll be starting the index from 1. So sorry, we need to start the index from 1, and we can keep a current sum, right? I will miss this one. Current sum, which will be nums of 0. Default, we will be initializing with the nums of 0. Okay, the current sum and max sum, max also. So whatever the things we added, right, only first element. So we are taking the first element now here. These are the initialization. So now we are going for index 1. So index 0, which means, yeah, in index 1 we will start from index 1, because index 0 is already taken for current sum and max sum. So for index 1, what will happen, the nums of I, and here the nums of I will be 1, and comma the current sum. So what is the current sum, nums of 0, 0 means minus 2. Here it will be minus 2, comma nums of I. What is nums of I? I means this one, 1 plus 1. So what will happen? 1 minus 2, it will be minus 1. So what is the maximum? 1 comma minus 1. So 1 is the maximum. Okay. Here what will happen? Already we assigned a new value to here 1. Current sum value will be 1 and the maximum value will be minus 2. So which is a maximum here? 1 comma minus 2. Which one is max? Max of 1 comma minus 2. So which will be 1. So both the values are now 1. So like this, the algorithm will repeats, and what will happen now? For example, let's say this is minus 2 and we are checking with 1. So how it will happen? It will just check the new, if something, for example, we are in minus 3 and we are going for 4 and we are just checking whether we will be checking with 4, right? So the new current sum will be 4. You got it, right? So like this, the algorithm will the same algorithm will repeats, and the maximum result it will give. This is for index 1 I mentioned. Same for index 2 also we can add. So we can add it for index 2. So index 2, what is the current sum? So it will be minus 3 here. Okay, nums of I will be minus 3. So nums of I will be minus 3. Now here it will be minus 3, and current sum will be 1, and nums of I will be minus 3. So minus 2. So it will be a max of minus 3 minus 2. Now it will take minus 2. Here is also the max here will be the current sum will be minus 2, and maximum sum which is already 1. So automatically it will be 1. So it will be no change in the max sum. So like this, one by one by one by one, the algorithm will repeats, and it will give the end result. So let me uh, let me write a code for this one. Okay, you can also repeat this index things, and you can get like the whatever I have written, right? The same way you can return up to 4. If you return now, you can see the maximum. What is the maximum you will be getting? That is the result. I will write a program, and after that I can explain this also one by one. Const we can give like uh, what function you can max sub array. This will be we can keep a name like Kadane. Okay, okay, fine. Now now you need to have only two things. We know, right? One will be initialization of the current sum. What we can initialize for the current sum? It will be num of 0, because already I mentioned here current sum max sum. What I will mention? Nums of 0. Zeroth index it will take by default. We need to make it for, sorry, and we need to make this one for max sum also. Okay, max sum current sum we initialized. Now what we need to do? We need to write a loop. Let I is equal to 0, I less than, oh sorry, I is equal to 1. I already mentioned, right? Here the 0 will be declared, so I need to give us length I plus plus. So one loop is written, this is written. What we need to do? Current sum, and one more thing, what we need to calculate? Max sum. For current sum, what we need to do? One is math dot max of, you need to check the value whether the nums of I is bigger, you need to take that value, else no, current sum plus nums of I. So this is the current sum, else max sum, right? Here what we'll do, we just check math dot max of whether the current sum is maximum or the max sum is the maximum. Whichever the result will be maximum, it will take that one. Okay, so this is also done. Now we just return the max sum, that's it. Okay, now I am going to call this function. Oh sorry, I will call this function now. Max, it will be Kadane algorithm KA. I am taking KA and I will mention max subarray Kadane of nums. Okay, now we got this everything. We are going to run this code. Now you see, right, all these three are getting 6. So we solve the problem. So using Kadane, it is will be the time complexity will be only order of n, and space complexity will be only order of n, so order of 1. So we are done with this. Okay, I will mention here, it will be here the space complexity will be more, like we are using recursive, right, recursive functions, so it will be order of same order of n log n. So we found that Kadane algorithm is an optimal one. So remaining two are having the complexity will be, time complexity will be more, and brute force is also having order of n power 2, and this one divide and conquer method is also having order of n log n, and here the recursive will be there, and the solution is also somewhat complex. But if you are checking Kadane, right, it will be clear and easy. So solution, and run it through the Leetcode, and you can see. Okay, I can run the problem. Okay, I run it through Java. Okay, I will select the JavaScript here, and I will run this code. Sorry, I didn't add the code. Okay, just now added. So now I have added the code, and I selected the code as JavaScript, and I have added the code also. Now it is accepted for case 1, case 2, case 3. Okay, now all the cases are matching. Now I can submit the code. I am adding the Kadane algorithm, right? That solution only. See here, all the 210 test cases are passed. So our solution got accepted in the Leetcode. So in interviews, you can always go for Kadane algorithm. In all the three approaches we saw, right? In that, better go for Kadane algorithm. It is simple, optimal, and widely applicable to subarray problems. And this is our overall. We can check the approaches. Okay, thanks for watching. If this helped you understand the Kadane algorithm and maximum subarray problem, so give it a like, subscribe for more DSA content, and comment which problem you want next. Okay, thank you.